In this video, I will show you how to evaluate trig functions using angle sum identities such as these. Throughout this video, I will assume that you have memorized certain basic facts by now, such as these. If you have not yet memorized, for example, that the sine of pi over 6 is 1/2, you need to pause the video and memorize this right now. We may wind up touching on some Pythagorean identities as well. So first of all, I am more comfortable dealing with radians than I am with degrees. So the first thing I'm going to do is convert the 255 degrees into radians. And I can do that by taking the 255 and multiplying by pi over 180. That is the conversion factor that turns degrees into radians. And really, this is just going to be a matter of reducing on my calculator. If I do 255 over 180, this reduces to 17 over 12. So 255 degrees is the same thing as 17 pi over 12 radians. Now the problem becomes cosine of 17 pi over 12. How do I do that? Actually, I'm not really ready to write this down yet. I want to discover a way of writing 17 pi over 12 using special angles like the ones on this chart, pi over 4, pi over 6, and pi over 3. So how can I convert this into a sum of special angles? A trick that I like to use is start by subtracting pi over 4. So if I take this angle in radians and I subtract pi over 4, what happens? Well, I am going to need like denominators, so I will have to multiply here by 3 in the numerator and the denominator. That will give me a common denominator of 12. So I have 17 pi over 12 minus 3 pi over 12. That's going to equal 14 pi over 12. Let's reduce that. So I have 17 pi over 12 minus pi over 4 is equal to 7 pi over 6. If I isolate the 17 pi over 12, I'm going to add pi over 4 to both sides. And that's going to give me 17 pi over 12 is equal to pi over 4 plus 7 pi over 6. Notice that I have now rewritten the original angle as the sum of two special angles. So 17 pi over 12 we find is equivalent to pi over 4 plus 7 pi over 6. So now we can continue with the problem. Cosine of 17 pi over 12 we now see is the same as the cosine of pi over 4 plus 7 pi over 6. Now's the time that we use our angle sum identities. The cosine of something plus something equals cosine cosine minus sine sine. So in this case, I'm going to have cosine of pi over 4 times cosine of 7 pi over 6. Notice that the plus changes to a minus, and then I will have sine pi over 4 sine 7 pi over 6. So cosine, cosine minus sine, sine. These are all expressions that we can evaluate using our knowledge of special angles. We know what the sine of special angles will be. For example, the cosine of pi over 4 we know is radical 2 over 2. That's right off the chart. When I look at the cosine of 7 pi over 6, 7 pi over 6 is not on the chart, but pi over 6 is. So the cosine of pi over 6 is radical 3 over 2. So that means the cosine of 7 pi over 6 will also involve radical 3 over 2. The only thing is, it might be negative radical 3 over 2. And the question is, what quadrant is 7 pi over 6 in? This is something you need to do in your head. If you realize that pi is the same thing as 6 pi over 6, then you can realize that 7 pi over 6 is going to be in the third quadrant. It's just going to be one angle past 6 pi over 6. So third quadrant. But please do that in your head. In the third quadrant, cosine is negative. Remember, cosine is an x value, and x values are negative in the third quadrant. So I'm not going to show all of that detail on every problem. I'm going to assume that you can do those basics by now. The sine of pi over 4 is radical 2 over 2, again right off the chart. We know that the sine of pi over 6 is 1/2. In the third quadrant, sine is negative, so it's going to be negative 1/2. Multiplying these together, and when you're multiplying with fractions, you multiply it straight across. So I'm going to get negative radical 6 over 4. Here I have a negative times a negative, so it's actually going to be positive radical 2 over 4. Notice that we do have like denominators at this point, so I can go ahead and write my final answer, which is negative radical 6 plus radical 2 over 4. Problem number 2 is already written in terms of radians, so that saves us one step. But now we need to take negative 7 pi over 12 and try to rewrite it as the sum or difference of special angles. And again, I will use the strategy of subtracting pi over 4. And just let's see what I get. Again, I will need like denominators. So I will multiply the numerator and the denominator by 3. This gives me negative 7 pi over 12 minus 3 pi over 12. So that's going to be negative 10 pi over 12. If we reduce all of this down, I have negative 7 pi over 12 minus pi over 4 is equal to negative 5 pi over 6. Adding pi over 4 to both sides, I get negative 7 pi over 12 is equal to pi over 4, whoops, not minus. All right, it's a positive pi over 4 because I added it to both sides, but then I still have this negative 5 pi over 6, so I'll say minus 5 pi over 6. So this is the key. Just going to erase all this real quick. Negative 7 pi over 12 is equal to pi over 4 minus 5 pi over 6. That means the original problem can be thought of as the sine of pi over 4 minus 5 pi over 6. So we can continue with the problem from there. Let's look at our angle sum identities for the sine of something minus something. All right, the sine of something minus something goes sine cosine minus cosine sine. So I'm going to have the sine of pi over 4 times the cosine of 5 pi over 6 minus the cosine of pi over 4 times the sine of 5 pi over 6. Okay, notice the pattern that goes sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Also, notice that the sign does not change the way it did for cosine. When we had cosine, it went from addition to subtraction. But for the sine function, subtraction stays subtraction. Anyway, we can quickly evaluate each of these parts. The sine of pi over 4 is radical 2 over 2. We've memorized that. The cosine of 5 pi over 6. Well, the reference angle is pi over 6. The cosine of pi over 6 is radical 3 over 2. The only question is, will this be negative radical 3 over 2? That depends on the quadrant. And here's what you do in your head. You think to yourself, over here on the left, this is pi, which can be thought of as 6 pi over 6. So then it should be obvious that 5 pi over 6 is going to be one angle short of that. So we're talking about the second quadrant. In the second quadrant, cosine is negative. So then I have minus. Cosine of pi over 4 is radical 2 over 2. Sine of pi over 6 is 1/2. In the second quadrant, the sine function is positive because it's a y value. So we have this. Multiplying straight across, we have negative radical 6 over 4 minus radical 2 over 4. So time to write the final answer, which is negative radical 6 minus radical 2 over 4. Notice that these sum and difference formulas also work in reverse. Look at this pattern, cosine, cosine minus sine, sine. Remind you of anything? Let's take a look at the sum and difference identities. Here we have cosine, cosine minus sine, sine. That's the pattern that you get when you have the cosine of something plus something. That means we can rewrite this as the cosine of the first angle plus the second angle. Notice that for cosine, it goes from subtraction to addition. Now, these already have like denominators, so we can actually add these together, and that will be cosine of 16 pi over 12. That fraction reduces, so this is like having the cosine of, I'm dividing both of these by 4, so this will be 4 pi over 3. This is something we can easily evaluate. The cosine of pi over 3 is 1/2. That means the cosine of 4 pi over 3 will either be 1/2 or negative 1/2 depending on the quadrant. And here's the part that you do in your head. You think to yourself, well, here's pi over here, and that's the same thing as 3 pi over 3. That means 4 pi over 3 is going to be one position past that. In other words, third quadrant. And cosine is negative in the third quadrant. So that's the answer. For number 5, I see sine cosine minus cosine sine. Let's check the identity sheet. Wrong one. Okay, so sine cosine minus cosine sine. That's the sine of something minus something. So that means I can rewrite this as the sine of the first angle minus the second angle. Notice that for the sine function, subtraction stays subtraction. We need like denominators in here in order to subtract. So I'm going to rewrite 5 pi over 9. I'm going to multiply both of these by 2, and that will give me 10 pi over 18. Sorry, I'm kind of squeezing this in. I've got 10 pi over 18 minus pi over 18. But that is 9 pi over 18. So this would be the same thing as the sine of 9 pi over 18. But this reduces down to pi over 2. So this will be the same thing as the sine of pi over 2. Of course, pi over 2 is up here at the tippy top of the unit circle, and sine is the y value. So that has a value of 1. So that's why the answer to number 5 would be A. Glancing at problem number 6, they're telling us that the angle is between pi and 3 pi over 2. So they're telling us that the angle is between here and here. Obviously, we are talking about quadrant 3. So note to self, the angle is in quadrant 3. We're given cotangent. Cotangent is the reciprocal of tangent. Tangent is y over x. That means cotangent must be x over y. Except for one thing. In quadrant 3, both x and y are negative. That means this must actually be negative 5 over negative 12. It's just that the negatives cancel each other out. Hold on, this negative sign is bothering me. Negative 5 over negative 12. So we have x, all right? X is negative 5, and we have y. What we need now is r. So let's go ahead and do some Pythagorean theorem. X squared plus y squared is equal to r squared. So that's going to be 25 plus 144 is equal to r squared. But that's going to be 169 is equal to r squared. And if you take the square root of both sides, you get r is equal to 13. So let's add that to the list. R equals 13. R is always positive. That's why I didn't do plus or minus. So now we have x, y, and r. We are supposed to evaluate the sine of 2 theta. So let's consult our double angle identities. 2 times an angle is equal to 2 times the sine of the angle times the cosine of the angle. So in my mind, I always shorten this down to 2 sine cosine. Okay, so we're going to wind up doing 2 sine theta cosine theta. So let's do it. Remember that sine is y over r. So that's why we had to find r. So sine will be negative 12 over 13. And then cosine is x over r. That's negative 5 over 13. Remember that this is like 2 over 1. So if I do 12 times 5, that's 60. And then I have to multiply that times 2. So that's going to be 120. Remember, a negative times negative is a positive. In the denominator, I have 13 times 13. That is 120. and 69. So this is the final answer. But what letter is that? Here we go. That would be answer choice C. So here will be the last problem on this video. Look at the pattern, cosine, cosine minus sine, sine. Which identity is that? Cosine, cosine minus sine, sine. That's the cosine of something plus something. So we can rewrite this as the cosine of the first angle plus the second angle. Notice one more time that when you're dealing with the cosine function, subtraction becomes addition and vice versa. So obviously we have some like terms in here. Negative 2x plus negative x is negative 3x. So this is the same as the cosine of negative 3x. So that's the answer. And that's B. In the next video, we will use our double angle and angle sum identities to solve trig equations such as these. If that sounds like something you're interested in, go ahead and click the link to watch the next video.